Dear students, welcome to another session of Nuclei chapter. Today we will be going to see something important, that is one thing about law of radioactive decay. Another one will be going to see some properties of the rays or the radiations. Okay. The first one is about alpha ray, and we have already discussed in the last class. Alpha is nothing but a helium nuclei. We will see some of the properties of alpha. So alpha is positively charged particle. Okay, alpha are called particles. Okay, alpha rays are particle and they are positively charged. Then when they incident on a photographic plate, they get affected. The photographic plate will get affected with the incidence of alpha particle. And that was one of the reason why alpha particle was discovered also. The Rutherford in the alpha scattering experiment, he saw that when the alpha particle incident on the photographic plate produced some kind of scintillations or a slight kind of blinking. Okay, so we can understand alpha particles are going to affect the photographic plate. Next one, they produce heating effect. Okay, if the alpha particle continuously gets incident on some surface or any substance, there is a kind of heating will be produced because of the energy from the alpha particle is supplied to that. Okay, it is also the heating effect produced. Then alpha particles are deflected to negative plate. Why they are deflected to negative plate? See, if I pass some alpha particle in a straight line, and if I keep two types of like a positive plate over here, negative plate over here, alpha particles are going to get deflected towards a negative plate. The reason that alpha particles are positively charged. So positively charged particles are always going to get deflected towards a negative plate. So that is one property. Then they will be going to deflect to the left in the magnetic field. So if you keep a magnetic field, they will be going to deflect towards the left of the magnetic field. Okay, because of the positive charge. Then they are less penetrating. So the property of the alpha of penetration is very less. You can even with a sheet of paper from your book, and you can block the alpha particle moving. Okay, the penetration ability of the alpha particles are very less. Then next one is about beta ray. Comparing exactly with the previous one, we are going to see the properties. Here it was positively charged, but you can see here in the next one, beta ray, it is negatively charged particle. Beta rays are negatively charged particle. They affect photographic plate. Obviously, energetic particle when get incident on the photographic plate will get affected. Then they produce heating effect. Obviously, the same explanation, they produce heating effect. Deflected towards positive in the electric field. See, I told you beta, actually there are two types, one positive beta, negative beta, but positive beta is a kind of less importance we are giving to that for the time being. Okay, we are only considering negative beta. Then if the beta particle is negative, obviously it has to get deflected towards the positive plate in the electric field. What about magnetic field? It is going to get deflected towards the right side in the magnetic field. Then penetration power of beta is 100 times that of alpha. So beta has got very good penetration power. It cannot be blocked just by your paper piece and all. You will have to go for like a thick iron foil, okay, or sheet of iron with very good thickness, so that you can block the beta particle. They have very good penetrating power. Next one, gamma particles. You must have known. In the previous class, I already explained about gamma particle. They are high energetic photons. They have got very high energy. So they come in the come on the last side. Okay. So in the last side of the electromagnetic spectrum. So they have high frequency and high energy as well. So they are uncharged. So alpha particle, gamma rays, they don't have any charge. Gamma rays, they don't have any charge, they have neutral charge, or we say zero charge. They affect photographic plate. Obviously, when the gamma rays incident on the photographic plate is going to get affected with that. then they produce high heating effect. Because of high energy of gamma rays, they produce high heating effect. Okay. They produce photoelectric effect when fallen on certain substances. Okay. So there is a chance, you must have already seen about photoelectric effect, right? When the radiation falls on a metal surface, electrons are getting ejected, and the same thing what the solar cell works. Same principle on which the solar cell also works. So there is a chance, like more chance, when the gamma rays fall on a metal surface, photoelectric effect will be observed. High penetrating power. Gamma rays has got the highest penetrating power, and you can see maybe in the nuclear power plants, the surface or the outer surfaces of the nuclear power plant will be like having a very thick concrete walls. At the same time, they will be fixed with many lead foils, or not the foils, lead bricks. Okay. Lead bricks will be fixed inside the nuclear power plant, and as well as outside will be like a heavy thickness concrete walls will also be there. And the reason why they are making this is to block the gamma rays. So you know, right, alpha and beta will have less penetrating power, but gamma has got very high penetrating power. So you need very good thickness of the material to block the gamma. Usually lead has got very good absorbing ability, so lead will be used to block the gamma rays. So they can destroy living tissues. So you must have the same nuclear power plant, you must have heard about like people getting affected with the cancer, whoever who lives like nearby nuclear power plant. And the nuclear power plant authority always checks the radiation level with the nearby places to see whether there is some leakage or other things within the nuclear power plant. So they can destroy the living tissues. It's a main thing when the gamma rays falls on a living tissue. What happens is the energy of the gamma ray will be supplied to the tissues, and the tissue will not have the ability to store that much energy. They will suddenly get burned or they get destroyed. Next one, rest mass of gamma ray is 0, because you know it is a photon. Okay, it is a photon. That's the reason why gamma rays doesn't have any rest mass. It will not be resting. Okay, it is produced and destroyed at the same time. Will conserved energy is conserved. Then gamma ray moves with the velocity of light. Gamma ray can move with the velocity of light, that it moves with the speed 3 into 10 to the power 8 meter per second. Next one is a very important 5-mark question, that is law of radioactive decay. Law of radioactive decay. When Rutherford and Soddy they were working with the radioactivity phenomenon, then they observed that the radioactive disintegration, like every unstable element will be undergoing disintegration, and he observed that when the radiation having or the element having highest number of atoms, okay, there will be the rate of disintegration is also very high. So on the basis of that, they developed a law, that is law of radioactive decay. The statement of the law says that rate of disintegration of atoms at any instant of time is proportional to number of radioactive atoms present in that instant. So if there are some 10 number of atoms, let's consider, then the disintegration is nothing but the decay process. Okay, energy is given out, and the element or the radiation coming out of this radioactive atom, and it becomes less active. Okay, it goes to the stable state. Then the radioactive decay actually proportional to the number of atoms present in that instant. When there are large number of atoms present in a particular instant, the radioactive decay will also be faster. In the first year you must have seen the Newton's law of cooling. It's very similar to the Newton's law of cooling, where you can see when the temperature difference is high, rate of cooling is also more, right? Similarly, when there are more number of atoms present, the rate of decay is also faster. Let's take N naught be the number of atoms present initially in the radioactive sample. Okay, N naught is the initial number of atoms present in the radioactive sample, and let N be the number of atoms present in the sample at any time t. Now we will go to the statement. According to the statement, we can write dN by dt is proportional to N. That is, rate of disintegration is directly proportional to number of atoms present in that particular instant. I can replace this proportionality sign with a constant. See here, dN by dt can be written as minus lambda n. What is lambda over there? Lambda is nothing but decay constant, or also called as disintegration constant. And why do we have this negative sign? So you also remember there in the Newton law you had negative sign, right? Similarly here also we have negative sign. The reason that negative sign indicates that n decreases with the time. So number of atoms decreases with the time. Okay, that is a process of decay is going on there. Now equation 1 can be written as, we will just interchange this over here, okay, and this dt will be taken to this side. Then I can write dN divided by n, that is equal to minus lambda into dt. Okay, we have to integrate the equation, and integrating on both the sides, what we are going to get for this one? Integration dN divided by n, that is equal to minus lambda. As it is a constant, you have to keep it outside the integration. You have already seen about integration, okay, or you will be going to see in your second PU mathematics the detailed idea about integration, or the first year also in physics also you must have come across such kind of derivations. Okay, so we will keep constant outside and we'll integrate dt. While integrating, we will get the value, that is dN by n, we will be going to get log to the power log to the base e n, that will be equal to minus lambda t plus c. So this c is nothing but integration constant. Okay, while integrating, it is a constant which we get with this integration, that is known to be integration constant. Now we have to do something. Let we will take the initial condition. So when t is equal to 0, what happens? We can substitute the values over here. T is equal to 0, we know that n is equal to n naught. So we will substitute these conditions on equation 2. Then you can get log to the base e, instead of n we have n naught. Okay, that will be like t is equal to 0, right? So what happens to this term? This term is going to become 0 over here. Therefore, what we get? We will be remained with the c. Then log to the base e n naught, that is equal to c. Now we get the value for c, right? We will substitute the c in the equation 2. Okay, that is c is equal to log to the base e n naught. We will substitute back to equation 2. I can write log to the base e n, that is equal to minus lambda t plus log to the base e n naught. Okay, now we will go for some rearrangement. What we are going to do is, we will take this log term to the left side. When the log term comes to the left, you know that what happens? The sign gets changed. So log to the base e n, that this is minus log to the base e n naught, that is equal to minus lambda t. Now you know how to deal with the log. Log a minus log b, it will be equal to log a divided by b. So what happened? Log n divided by n naught, that is equal to minus lambda t. When you take this log to the other side, it actually becomes e. So what do you get? N divided by n naught, that is equal to e to the power minus lambda t. Okay, when log is taken to the other side, it is log to the base e. It becomes n divided by n naught, that is equal to e to the power minus lambda t. Now I'll take this n naught also to the other side. Then what do I get? I get n is equal to n naught e to the power minus lambda t. So this is the statement for law of radioactive decay. Okay, so that is what we have taken as equation 2. So up to here you have to solve, and you will be having 5 mark question from this. Okay, you also have to go with the graph, then only you will get 5 mark. Graph might carry 1 mark. It is clear from equation 3, okay, n will be equal to 0 only when t is infinity. So n will be going to become 0 only when this t term becomes infinity. So what is the meaning of that t becomes infinity? Infinite time. That means it is never going to become infinity. So radioactive substance never going to get disintegrated completely. It is not going to disintegrate completely. It is because the radioactive decay obeys exponential law. Radioactive decay obeys exponential law. We will see this graph. It actually deals with the same radioactive decay law. You can see here, so let n naught be the initial number of atoms. As time increases, you can see that number of atoms goes on decreases. Okay, so at any particular instant, if you take the number of atom, it can be calculated by knowing initial number of atoms with the exponential of constant decay constant with the time. Okay, so as the time increases, number of atoms goes on decreases, and you can see here this never touches 0. So it never touches 0. That means the number of atoms never going to get disintegrated completely. Okay.